Okay. Okay. Today we are going to discuss about our very new lesson, that is mechanical properties of matters. That is a physics lesson. Physics lesson, as you already know, that's a physics lesson, and it also a very small lesson. Actually, it's not a long lesson, and very it don't have more notes. More notes. Very simple. Few equations. Few equations, and this lesson contains some two theorems. The first one is Hooke's law. It is H double O H, H double O K. It has the theorem like Hooke's law. Hooke's law. Hooke's law. And the next one, Young's module. Young's module. They are the theorem we need to discuss under this lesson. If you complete the basically we mainly discussed about mechanical properties of what are the mechanical properties and what are the main types of mechanical properties and their differences and their uses and functions. Everything we discussed, and their relationship also we discussed. Using their relationship, we prepare a few equations as well. We need from this equation we doing some calculations as well. Okay, that's a nature of this lesson. That is, the name is mechanical properties of matter. Okay, this lesson I have actually not, but I hope to give you a written note, because it don't have any long note. It's very small lesson, but a lot of exam practical questions are coming from this lesson. If you go through our practical books in our final part of the lesson, we discuss this full practical guide, practical book we discuss. Then you can find 2 to 3 actually, the elongation, strain, and Young's module. There are 3 practicals are there in these books in from this lesson. Okay, therefore first of all we need to and today we are going to start the theoretical part of the lesson. Then after you understand theoretical part, we can discuss the practicals after that. Okay. Okay, write down the topic, the mechanical properties of matters. 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 Okay, now we need to simplify this topic. The topic has 2 different things: mechanical properties of matters. Okay, before we discussed about mechanical properties, first you need to understand what is the meaning of what are the matters. You already know, as yesterday our fluid mechanism also we discussed. The matters are mainly 3 type, as you already know in O-level time: solid, liquids, and gases. Solid, liquid, and gases, they are the matters. Physical status of matters. Matters mean using molecular, they produce compounds are the everywhere in the world. They are matters. They are matters. The matters can be solids, liquids, or gas. Okay, then what is the meaning of this? Properties of matters. Properties of matters. Properties, when we consider about the properties of matters, mainly there are 3 main types of properties of matters. In physics, we discussed there are three main types of properties of matter. The first one is the first property is electric properties of matters. Electric properties of matters. Electric properties of matters. The first property of matters, it is electric properties of matters. Electric properties of matters. The second one is physical and chemical properties of matters. In physics, we mainly discussed the first one is there are three main properties of matter. The first one is electric properties of matter. The second one is physical and chemical properties of matters. Physical and chemical properties of matters. Physical and chemical properties of matters. The final one is the mechanical properties of matters. Mechanical properties of it is not M-A-M-E, mechanical properties of matters. Okay, they are the still we discussing about properties of matters. Matters, you already know, matters mean everything, everywhere in our world contain matters, solids, liquid and gases. They all are matter types. Then I told, when we consider about properties of matters in physics investigations, we consider main three types of properties of matters. The first one is electric properties of matters. The second one is physical chemical properties of matters. The final one is the mechanical properties of the matter. Mechanical properties of the matter. The first part, electric properties of the matter, we discussed in our electricity lesson. It is this one we discussed in our syllabus electricity lesson. The physical properties of matters mainly we discussed in our heat lesson. Okay, that is electricity lesson. That is in heat lesson. Chemical properties of matters, as you remember, still you don't know, right? In our thermal chemistry and kinetic chemistry, we discussed about chemical properties of matters. How reactant in molecular level, how reactant convert into product, everything. Chemical properties of matters we discussed in the thermal chemistry, kinetic chemistry lessons. Okay, this also we discussed. Okay, now, but this lesson, specially we discussing about mechanical properties of matters. Specially we discuss mechanical properties of matters in this lesson. Are you good? I think you can understand what we're going to discuss. In this lesson, especially we going to discuss, especially narrow down into the mechanical properties of matters. In this lesson, especially we going to focus into the mechanical properties, especially. In other properties, we discussed in different lesson, but in this lesson, we going to discuss about mechanical properties of matters. Okay, do you have any idea what are the examples for mechanical properties? Do you have any idea? Mechanical properties of matters, example? Can you send me? What are the examples for mechanical properties? Any idea? I'll give you one. The elasticity is a one. Elasticity. Elasticity is a one mechanical property. What are the examples in your day-to-day life? Yeah, strength. The strength also one mechanical strength. 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 Th. Strength. What are the mechanical properties of matters? Very good. Hardness. Very good. Hardness. Hardness. Compression. Very good. Compression. Compression. Okay, what are the examples for mechanical properties of matters? Mechanical properties of matters. Example. The elastic opposite side, that is plasticity. Elasticity, plasticity also a mechanical property. Plasticity. 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 What are the examples? Brittleness, very good. Brittleness. 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 Other example? Ductility, very good. Ductility. Ductility. Toughness, very good. Toughness. Toughness. Okay, there are more than 100 mechanical properties of matters we can found. The mechanical properties. Simply, they are properties, okay? Matters, mechanical properties. What are the malleability? Yes, malleability. There are different types. Malleability. Okay, there are different types of mechanical properties. We can find more than 100 also. If you search in the internet, you can find different types of mechanical properties of matters. But in this lesson, we going to mainly discuss about properties. I will explain one by one. We not going to discuss every mechanical properties, but we going to discuss about only few mechanical properties to understand these theorems. As I explained earlier, Hooke's theorem and Young's module, understand only basic things we discussed in this lesson. We not going to discuss all mechanical properties of matters in your A level type, A level syllabus. We going to discuss important few mechanical properties, and we going to their relationship, how combined with these theorems, Hooke's module and Hooke's theorem and Young's module, that we call as Hooke's law as well. Okay, that's so you can discuss at the last part of the lesson. First, we need to discuss the basic part we require to understand this theory. The basic mechanical properties we need to discuss first. Okay. Okay. Before that, write down the basic, the first point. The topic is mechanical properties of matter. Mechanical properties of matters. Properties of matter. Mechanical properties of matters. Okay, first point. When consider about properties of matters, when consider about properties of matters, there are three types. When consider about properties of matters, It's mainly three types. Write down first one, electric properties of matters. The second one, physical and chemical properties of matters. Third one, mechanical properties of matters. Mechanical properties of matters. Mechanical properties of matters. Mechanical properties of matters. Electric properties of matters, physical and chemical properties of matters, mechanical properties of matters. Okay, write down with star mark below, write down star mark. In this lesson, we mainly focus the mechanical properties of matters. We mainly focus into the mechanical properties of matters. Mechanical properties of matters. Okay, now write down, so this point, write down examples for mechanical properties. Examples for mechanical properties of matters. Then write down few examples, no need all. Few examples you can note down. They are the mechanical properties of matters examples. Examples for elasticity, plasticity, strength, ductility, malleability, plasticity, brittleness, ductility, toughness, compressibility, hardness, strength. The other, if you search more than these, the properties, you can find more and more mechanical properties you can search. Okay, but in this lesson we not going to discuss every properties. We only discussed important few properties to understand these theories. Complete. Okay, if you complete, write down the first mechanical properties of matter. Write down the first mechanical properties of matter as subtopic. Write down elasticity. Write down first mechanical property as a subtopic, elasticity. 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 Okay, now you need to practically understand what is the meaning of this elasticity. Okay, what do you think? Yeah, last day also I explained. You can get a rubber band like this. Rubber band. Rubber band. This is a rubber band. Okay. That is actually elastic. That's a elastic matter. Now, elasticity mean elasticity simply, if you understand, when we apply external force, elasticity mean when we apply external force, it's deforming. Deforming mean actually its size length is increasing, but if I release, again come to the same position. Again, if it is come to the same position, that we called as elastic object, elastic matters. When we apply external force, it is deforming, and when I release this force, it is come to the same position. Okay, it is come to, if it is come to same position, it's not for only rubber. There are different types of elastic objects. The plastic also, plastics, elastic or plastic, elasticity or inelasticity. Plastic depends. Plastic depends. If I consider about it is vulcanized rubber, I told you in polymer lesson we discussed about rubber vulcanization. Rubber vulcanization, after vulcanize means tires, shoes are produced after vulcanization. Rubber vulcanization. The vulcanization means rubber, natural rubber. This is natural rubber. The natural rubber elasticity decreasing, and their strength, their stress is increasing. Their stressing ability, their strength is increasing. Okay, that's process we called as rubber vulcanization. In this rubber vulcanization process, it is converting, the elasticity characteristics are decreasing. Elasticity characteristics are decreasing, as well as some plastic as well. Their elasticity, if it is very hard plastic, it is, its elasticity is very low. Okay, except rubber, what are the other elastic objects? What you know? Elastic objects. What are the elastic objects? Examples for elastic objects? Example, except rubber. Yeah, then it rulers mean you need to mention the matter. The ruler is object. It can be rubber ruler. Yeah, springs also. Springs, yeah. I want matter. The rubber is a one matter type. I ask other matters. If I say the woods are elastic, can you believe this? Woods, Lee, natural woods, they are elastic. That means when we apply external force, it is deforming, then it is releasing, it's come to the same position. We can't, that's mean elasticity mean if I given any external force, it cannot retain. Okay, it's only for certain limit. We discussed everything in this next part. Now the natural woods are elastic matter. Okay, what do you think others? Yes, very good. Some, not some metal. All metals are elastic. All metals are elastic. Yeah. Rehlan, springs mean, the springs mean, you need to mention the matter type, like this. Woods are natural woods. They are elastic up to certain level. The rubber also up to certain level elasticities. the elasticity available for rubber also up to certain level, not unlimited, not unlimited. The woods also same, metals also same. Can you imagine the glass also elastic objects? Glass up to certain level, glass also elastic. When we apply external force, it is deform and come to same position. Glass also elastic. Glass also elastic. Okay, metals, woods, what? Rubber. Rubber is a main elastic object. Rubber, natural rubber. They are the main. Normally, structure polymers are not. They are very complex structure polymers like vulcanized rubber. We not consider as plasticity object, but if it is the structure is very simple structure polymers like in the polymer lesson we discussed about the chain growth polymers. They are simple structure polymers. They have elasticity characteristics. Okay, mainly they are the examples for elasticity. If you you just need to understand the meaning of the elasticity. When we apply external force, it's deforming, and when it is released, it's come to a same position up to certain level. Up to certain level, it not unlimited. We can't apply external force unlimited on this rubber also. It is breakdown. Samely, these other materials also, when we increase the external force up to after this limit, it is breakdown. It's correct, but they have elastic property up to certain level. Up to certain level. Okay, then if you understood the inelasticity, inelasticity means plasticity. Inelasticity, the second one is inelasticity. Inelastic object, elastic matter, that means plasticity. Plasticity means when we apply external force on this object, it is deforming, then again not come to the same position. That's the meaning of inelastic objects or plasticity object. Can you suggest a few examples for inelastic object? Inelastic objects. What are the examples? Very good. Clay is a good clay is a good example for inelastic. Clay. When we apply external force, it is deforming. Again, not come to the same position. Again, not recover. Okay. Others, the papers also. Papers, cardboard, papers, mainly papers, and cardboard also. They are inelastic objects, inelastic matters. Inelastic matters. Yeah, grease like, yeah, correct. Grease like, yeah, cheese, yeah. Whatever the solidified matters, everything inelastic. That means plasticity. The plasticity means if we increase in the future parts, you can understand. If I increase in elasticity object up to certain level, it has a retained capacity. Retained capacity means up to certain level, it is retained. It is not breakdown. Inelastic plasticity object before this level, even in a very small force, they are breakdown. We discussed in this lesson. In the future parts, we discussed when we apply external force on the rubber tube, what are the steps it is passing, what are the steps. There are different levels as naming proportional level, elasticity, plasticity level, breakdown level. There are different um, stages we discussed, point by point stages we discussed. Then finally we discussed what are the difference between elasticity object and plasticity object, what are the their stages difference. Everything we discussed in this lesson in future parts. Therefore now first of all you need to get a brief idea about what is the elasticity and what is the plasticity difference, elasticity and inelasticity difference. Okay, write down first one, elasticity, subtopic number one, elasticity. Subtopic number one, elasticity. Write down, when apply external force on any matter, when apply external force on any matter, when apply external force on any matter, it's deforming and after releasing the force, after releasing the external force, after releasing the external force, if it is come to the same position, if it is come to the same position, this type matters, if it is come to the same position, this type matters are called as, this type matters are called as elastic matters, elastic matters, elastic matters, elastic matters. Write down examples: woods, natural woods, metals, glasses, rubber, natural rubber, natural rubber, natural rubber, natural woods, natural woods, metals, glasses, and natural rubber. They are the examples. Elasticity of elasticity matters. Elasticity matters with elasticity mechanical property. Matters with elasticity mechanical property. How we remember the elasticity meaning? When we apply external force, it is deforming, and release, it's come to the same position. Release, it's come to the same position. Release, it come to the same position. That we called as elastic matters. Elastic matters. How you explain that? When we apply external force, it is deforming, and when it is releasing the external force, it's come to the same previous position. That we called as elasticity matters. Elasticity matters. Elasticity matters. Okay, write down subtopic number two, inelasticity, within bracket plasticity, inelasticity, plasticity, within bracket inelasticity, inelasticity, within bracket plasticity, within bracket plasticity. Write down. When apply external force on any matter, when apply external force on any matter, the shape is deforming and the shape is deforming and the shape is deforming and when it is releasing, if not come to the same position, if not come to the same position, when it is releasing, if not come to the same position, if not come to the same position, this type matters, this type matters are called as plasticity matters. This type matters are called as plasticity matters. Plasticity matters. This type matters are called as plasticity matters. Plasticity matters. Examples: clay, papers, clay, papers, clay, papers. Okay, they are the main two. They are the main two types of mechanical property we going to discuss in this lesson. Okay, sorry. Okay, they are the main mechanical properties we're going to discuss in this lesson: elasticity and inelastic objects. In this lesson, our other parts we mainly discussed about this based on this property. Based on this property. Okay, we'll see. Okay, write down one, third one, third one, elongation. Elongation. The third one is elongation. Within bracket extension කියලාත් කියනවා. Extension. 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 The symbol is E. The symbol is E. Extension. The symbol is E. The mechanical property is elongation. 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 They are not actually mechanical properties. A few properties of elastic objects. Elastic object properties. Okay. Okay, now I will explain. Okay, now the elongation. Oh, this is our next property we need to discuss. That is elongation. Elongation, when we think this is an rubber mat, rubber tape. Okay, rubber tape. This is an rubber tape. This is rubber tape. That's the initial length that we called as L1. The L1 is the initial length of this rubber tape. The L1 is the initial length. If I put external force on this rubber tube, external force on this rubber tube like this, if external force on this rubber tube, what happened? The length is not decreasing. The length is increasing, no? The length is increasing up to this level. Think the length increase up to this level. Length increase up to this level. Length increase up to this level. Then you can see, you can identify this is the final length that we called as L2. L2. This is the final length. This is the final length. It is L2. It is L2. Then the elongation or extension mean when we apply external force on any object. When we apply external force on any object, the length increasing amount, the length increasing that in simply the elongation equal L2 minus L1. L2 minus L1. The final length minus initial length. In other words, the delta L is the delta L is the length difference. The delta mean difference, no? The length difference in the is the that we called as elongation. Elongation mean when we apply external force on any object, the length increasing or decreasing amount. It can be increased or decreased. Normally we call extension for increasing. Normally we call when we apply external force, the length is increasing, but if we apply external force into external force into opposite direction, it can decrease. It can decrease, but in this stress part we can discuss these things. Now mainly elongation mean the length increasing amount. The length increasing amount is the දිගේ වැඩි වන amount එක තමයි that we called as a elongation. Elongation, this part actually you need to understand few words only. This parts, the basic first only few words, then finally we can get the relationship between these that's the nature of this lesson. Actually this lesson, the basic part don't have any relationship between these topics we discussed, but finally we can get relationship between them. Then we can go to the get these modules. Get this module. That's a very important lesson. If you can't remember, if you can't understand these basic theory parts, basic theory part, if you don't know the meaning of these words and theories, what is elasticity, what is the plasticity, what is elongation, what is the strain, what is the stress, what types of stress, and what, if you can't understand, if you don't know these things, these basic theories, you can't understand final any modules, you can't understand theories, you can't understand. And in other hand, you can't understand any practical component of this. Okay, therefore this basic part is very important. Now the elongation mean when we apply external force on any object, the amount of length increasing. Think this one, when we apply external force, the length is increasing amount, that we called as that is final length minus initial length. Final length minus initial length, the elongation equal final length minus initial length. Final length minus initial length, it is the elongation. In other words, the elongation equal delta L, the length difference. The length difference is the elongation. Okay, now the elongation is okay. Do you have idea what is the unit of this elongation? What is the unit? What is the standard unit for this elongation? Elongation, what is the standard unit? Elongation. Standard unit? Any answer? No idea? I ask simply, what is the standard unit? Very good. Others? Yes, it is meters. No, why? It is a length. It is a length. Normally, for elongation expression, we use millimeters as well, because some object, when we apply external force, only increase few 0.0 type millimeter value. Then, but standard unit is meter. The standard unit for elongation, standard SI unit, SI unit for elongation, SI unit for elongation is meter, because it's a length. No, it's a length. The standard unit is meter. Okay, write down the third topic, elongation. Elongation. Within bracket, extension. Extension. The symbol is E, simple E, not capital E. Okay, simple E. The symbol is simple E. Symbol is simple E. Okay, before write the note, better to draw this one. Draw this and draw this diagram and write down elongation equal final length minus initial length. The elongation E equal L2 minus L1. It is delta L. It is delta L. Okay, I think you can get the full idea from this diagram. Completed? Quickly note down. Very simple things. This is actually elongation mean. Now think the elongation is example. Now it is, wait, now it is 10 centimeters. When we apply external force, it's increased up to 15 centimeter. Then the elongation is 5 centimeter. In final 15, initial 10, then the length difference. The length difference is the delta L elongation. Simple. Delta L is the elongation. I complete. Send message. Okay, write down. Write down the first point. First point. While apply an external force on any object, an external force on any object, while apply an external force on any object, the length increasing amount of the object, comma, the length increasing amount of the object is called as the elongation. The length increasing amount of the object is called as the elongation. It's called as the elongation. Elongation. Next point, the elongation can be found. The elongation can be found. The difference between the elongation can be found. The difference between the elongation can be found by the difference between final length of the object and the initial length of the object. Final length of the object and the initial length of the object. Final length and initial object. Sorry, final length and initial length. Difference between final length and initial length, that's also correct. Therefore, the standard unit of elongation is meter. Therefore, the standard unit for elongation is the meter. Okay, that's the elongation. Extension. Both is starting from E, no? E. Simple E, not capital E. Simple E. Okay, I think up to now, okay, send me message. Up to now, our discussions only. I know you can't understand relationship between, actually don't have relation. Now we, if you understood the meaning of these words, that only I need. Then finally we can summarize and we can get relationships. Are you okay up to now? The meaning of this word signing. Okay. Okay. We're going to move into our fourth topic. It is strain. 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 Their Sinhala words are totally different. Okay. The elongation Sinhala word is with a thea. It is totally different. The strain Sinhala word is Vikriyava. Vikriyava. Strain. The strain symbol is like this. It's like this, not like. Wait, I can't remember actually. That we use like this. Like this. It's a Greek letter. It is Greek letter. It's like this. Not like this actually. The one is small. Like this. Like this. That's a Greek letter. Yeah, yeah, sigma, sigma. That's sigma mean yeah, is it sigma, no? Then what's the name for this? I have mixed up now. This symbol, wait, symbol sticker mixer. Yeah, is it epsilon? Yeah, this is the sigma, no? This is the sigma. The sigma for our next, the symbol for our next topic. It is stress. Stress. They are not English letters. They are Greek letters. That is this name no need. Remember, this is the symbol for strain. This is the symbol for strain. These Greek letters you don't need to remember. Only symbol, actually symbol also don't need, but in your calculation you can use this symbol for as instead of strain word, you can use the symbol. Okay. Now the strain, if it is symbol is difficult, the strain, the theory is very simple. The theory, the strain mean the ratio between the initial length, this diagram, this L, the ratio between, very simple, the ratio between L1 and delta L. The ratio between L1 and delta L we called as a strain. Strain mean the L1 strain equal strain equal elongation that means E or delta L in elongation over initial length. Elongation over initial length that we called as a strain. The ratio between the delta L and L1. The ratio between elongation and initial length of this object that we called as strains. Then we can say the strain equal elongation mean delta L or E initial length is L1. This is the equation for strain. That means delta L over L1, or E extension over L1, elongation over L1. Okay, what you can say about the unit of this strain? Standard SI unit of strain. SI unit of strain. Very good. It don't have unit. Why? The delta L, that means extension unit is, elongation unit is meter. L1 initial length unit also meter. Then meter to meter cancel out. No, meter to meter cancel out. Therefore, the strain don't have any unit. No units. Okay, write down, then you can note down this. Write down first point. The ratio between elongation and initial length of any matter called as the strain is called as the strain. It's called as the strain. It's called as the strain. Okay, now write down strain equal elongation over initial length. Strain equal delta 1. SI unit of strain. It don't note down this. Complete. Strain. The strain mean the ratio between the elongation and the initial length. If you consider about, are you complete? If you complete, try to understand this. They actually don't need up to this level, but I will explain. The strain mean actually, if you try to understand this by this equation, the strain mean actually what happened when you increase the delta L according to this equation. When increase the delta elongation increase mean what happened? The strain is increasing. The elongation increase, the strain is increasing. The L1 increasing, the strain is decreasing. Okay, you already know that C called as directly proportional and inversely proportional, as common as physics in other equations. Okay, now the strain is simply like retaining capacity, like it's retaining capacity, that like breakdowning possibility like thing. Okay, breakdowning possibility. When it is the elongation increase, the strain value is increasing. When the initial length increase, the strain value is decreasing. That we can discuss more in the next part. Okay, now if you have basic idea, that enough. That is a very simple lesson actually. You don't have more advanced things. Very simple things need to discuss. After that, they are relationships only. Okay, we're going to move into our fifth topic. That is the most important one, the stress. Stress. Okay, what is the meaning of this stress? Do you have any idea? The stress mean actually that you already know. The stress mean, think we have elastic object. If I select 1 square meter, that means unit area that you already know as a different name, but now you need to understand these both are same. Okay, now this is a 1 square meter. That 1 square meter mean unit area. If I applied external force into unit area, external perpendicular force into a unit area, the force must be perpendicular to this unit area. Okay, the force must be perpendicular mean, think this is the surface. This surface and force must have a 90-degree angle. Then according to your O-level knowledge, what is the name for that? The perpendicular force act to a unit area. What is the name? The perpendicular force act on unit area. Very good. Yesterday we discussed, no? In 2025 class. Others, the perpendicular force act on unit area. What is this? That we called as F over A. What is the name? Force over area. In O level, what is the name? What's the name for this quantity? Very good. It is pressure, no? The pressure equal F over N. The pressure equal perpendicular force over area. Now, the stress means same thing. The stress mean same as pressure. Actually, the stress mean the perpendicular force act on unit area on a elastic object that we called as stress. A pressure ekatama, that's a different name if it is act on an elastic object that we called as stress. Stress. Okay, now I think you got the stress meaning. The stress same as pressure. Stress is same as pressure. Stress is same as pressure. Stress is same as pressure. If it is act perpendicular force on a elastic object that we call as a stress, not consider as it as a pressure that we especially we understand it is the stress. It is a stress on this elastic object. It is a stress on this elastic object. Okay, now the stress equal same thing. The stress equal the perpendicular force. It must be perpendicular. I think now you have idea what's the meaning of perpendicular. The perpendicular mean 90-degree angle from the to the surface. 90-degree angle to the surface. Perpendicular force. Perpendicular force. Perpendicular force over area. Perpendicular force over area, then we call the perpendicular force into a unit area, into an unit area of a elastic object that we call the stress. Okay, I'll give you definitions. Okay, now this is the stress. Then sorry, the stress symbol is, it is like this. It is like this. The symbol is like this. Then we can say the stress is the perpendicular force F. Perpendicular force F. The area is A. Then what is the unit of this? What is the unit? Unit of this stress? Very good. You already know the force unit is Newton. The area unit, standard unit is square meter. Then Nm minus 2. Newtons per square meter is the unit. Newtons per square meter. Per square meter is the unit. Now, I told in the still you not did the pressure fluid mechanism, no? In the pressure lesson, we discussed 1 newtons per square meter is equal to 1 pascal, no? 1 pascal. Therefore, the standard unit is pascal, not Nm minus 2. The Nm minus 2 is the unit, but the standard SI unit, standard international unit is pascal. That's also we using. This is the standard unit, same as pressure. Okay, it is same as pressure. Only difference it is act on an elastic object. In this case, we consider that is the stress. That is the stress. I got up to now. Only we discussed few words. Few words. Up to now, you need to understand the meaning of each words only. Others, are you good? Rehlan? Yeah, when comparatively other more complex lessons, this lesson is little easy because no more very complex things, all are very simple. Okay, write down topic stress. Topic number 5, stress. Stress. Write down point number 1. Point. The perpendicular force, sorry, a perpendicular force, a perpendicular force, a perpendicular force act on act on a unit area. Act on a unit area. The a perpendicular force act on a unit area of any elastic object. Unit area of any elastic object is called as the stress. Is called as stress. It's called as the stress. The perpendicular force act on a unit area of any elastic object is called as a stress. Is called as a stress. Okay, first draw this, then write down the stress equal perpendicular force mean F. Perpendicular force mean F. The area capital A. Then note down like this. Complete? Complete? Okay, now do you remember all we discussed up to now? First we discussed about what? First we discussed about elongation. The elongation mean delta L, final length minus initial length. Elongation, I think, easy. One is what? strain. The strain mean elongation over initial length. E over L1. E over L1 or delta L over L1. The strain don't have units. It means the perpendicular force over area, the unit is Nm minus 2 or Pascal. Nm minus 2 or Pascal. Okay, now the stress is mainly two type. Stress is mainly two type. Stress mainly two type. Stress mainly two type. The first one is tensile stress. Tensile stress that we call as tensile stress. Tensile stress. The second one is compression stress. Compression stress. Compression stress. Okay, from these words, the first one is the stress is you already know now. The stress is already know. Now the first one is tensile stress. The second one is can you get the difference between compression stress and tensile stress? Can you get the difference? Can you imagine? What is the difference? Can you imagine? Tensile stress. If you have any idea, no need the full definition. I need, if you have idea. Tensile and compression. Okay, the words also explain the meaning. The tensile stress mean it's like this. I will explain both difference in a diagram. The tensile stress mean think this is a object. This is a rubber or whatever elastic object. The tensile stress mean the perpendicular force act like this. Perpendicular force acting like this. That means with this, that we called as tension force, tensile force. The stress generated due to tensile force. Tensile force the actually because of this tensile force, the length is increasing always. Not length is increasing. You can see if it is applied force into the, as it is the length increasing, the size is increasing, that we called as on the surface generate tensile stress. On the surface generate tensile stress due to this tension force. It is a tension force. The length is increasing. The length is increasing, that we called as tensile stress. On the surface generate stress that we called as tensile stress. Okay, the second one is compression stress. Mean same thing. Think this is the object. This is the object. Now the force is applied like this. The force is applied like this. Now what happened? The length is decreasing. The compression. On this point, on this surface generate stress that we called as compression stress. On this surface generate stress that we called as compression stress. Compression stress due to applied external force. That this force, this type force we called as, that is a tension force. Tension force. Tension force. This type force we called as compression force. Compression force. Compression force. Compress force. Compress force. Compress force. Okay, that's the main difference. The force applied direction is depend according to this tensile stress and compression stress mainly depend on the force applied direction. Force applied direction, if it is force applied as a tensile force to increase the length, that we on this surface generate tensile stress when it is force applied into the opposite direction while decrease the length of the object as a compression force that we called as compression stress on the surface generate compression stress. Understood the difference? Quickly send me. Any doubt up to now? Ama, it's 9, 10 or 50. But actually, I don't know what is the finishing time. If we complete today works, then class is finished. 9 to 9:15 we will finish. Okay, if you turn off your phone, you can watch the recording now. Okay, write down with star mark. The stress of objects. The stress of elastic objects can be divided into two main types. The stress of elastic objects can be divided into two main types. First one, tensile stress. The second one is compression stress. Tensile stress, compression stress. First one, tensile stress. Second one, compression stress. Write down the topic 1, tensile stress. Subtopic 1, tensile stress. Tensile stress. Write down under tensile stress. Write down the stress generate on a elastic object due to tension force within bracket as increase in the length of the object. Within bracket as increase in the length of the object. As increase in the bracket as increase in the length of the object. As increase in the length of the object is called as the tensile stress. is called as the tensile stress. Tensile stress is called as the tensile stress. Is called as the tensile stress. Is called as the tensile stress. Tensile stress. Okay, then write down tensile stress equal. Tensile stress equal. Tensile stress is tension force. That should be, sorry. Perpendicular tension force. Perpendicular tension force. Perpendicular tension force. Perpendicular tension force. Tension force. Perpendicular tension force. I will write in a new page. Tensile stress equal perpendicular tension stress, tension force, perpendicular tension force over area. Simple, only the perpendicular force type is changing. Tensile stress equal perpendicular tension force over area. No any difference, the unit is same. The unit is Na-2. The unit is same, the others are same, only this additionally word is coming. Additionally word is coming, it is a tension force is coming. That's only. Very simple. It's like a O-level lesson. Tensile stress equal perpendicular. But these words are little bit new for you. When you practicing, when you it calculations after to familiar, I know confusing, think about this that we can practice. Other things, its meanings that actually this lesson is very simple. Okay, write down topic number 2, compression stress. Compression stress. Sorry, compressive stress. Compressive stress. Compressive stress. Tensile stress and compressive stress. The force is the compression force. Compression force. Compressive stress. Compressive stress. Write down. The stress generated on an elastic object. The stress generate on an elastic object. An elastic object. The stress generate elastic object due to compression force. Due to compression force. Within bracket as decrease in the length. Within bracket as decrease in the length. Called as the is called as the compressive stress. Compressive. The force is the compression force. Compressed force එකක් නිසා the stress generate that we call as a compressive stress. Compressive stress. Okay, then the compressive stress also same. The compressive stress, note down this, compressive stress is perpendicular Which force? Perpendicular compression force. Compression or compression force over area. Over area, very simple. F over A. Only one word is adding. Only one word is adding. Only one word is adding. Perpendicular compression force divided by area. Okay, now before we go to the calculation, basic part is done. Basic part is done. We can do few calculations. New words. We can do few calculations and check our understanding. Okay, now draw this chart and complete the basic part. Stress, 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 tensile stress, compressive stress. Draw this figure and prepare a short note. Short note. This compressive stress force we called as compress force or compression force. Compression force. Compress karana force. That's why due to this compress, the length is decreasing. The length is decreasing due to this compress. If you complete, quickly send message. Now we are going, the basic theory part is complete now. If you complete a few uh, calculations, then today lesson is complete. Then actually within 3 days this lesson is complete. At the final week of this month we discuss the tutorial, all questions of lesson, exam questions and all past paper questions. Then this within this month this lesson is complete. Okay. Then how many lessons we complete now? This is our ninth lesson, no? Ninth lesson: forces, measurement, area, volume, trigonometry. Yeah, all basic lessons now covered. Biomolecules. Last month we discussed coordinate geometry and work energy power also we did. Now this is our ninth lesson. Then we have only few lessons. Actually now interesting lessons are starting now. After this one we start the kinetic chemistry, thermal chemistry, chemistry lessons, and some after that we start the statistic as well. Statistic is a long lesson. Statistic, and after that we discuss about what in sorry other chemistry lessons, natural products, industrial chemistry. We start probably within few months we can complete. Then I think this class we can complete the syllabus before 4 to 5 months before the exam we can complete. Now 25 class little bit late, but this one also we complete. Okay, question number one. Question number one. Draw this. Okay, complete. Anyone send me message? I complete the figure. Question number one figure. Okay, write down. Write down the question. 7 centimeter radius and 60 centimeter height. 7 centimeter radius and 60 centimeter height. Cylindrical rubber tube. 7 centimeter radius and 60 centimeter height cylindrical rubber tube is given in the figure. Is given in the figure. Is given in the figure. 500 Newton external perpendicular force. 500 Newton external perpendicular force act on the tube and its length increasing from 68 centimeter. Its length increasing from 60 centimeter to 68 centimeter. 60 centimeter to 68 centimeter. 60 centimeter to 68 centimeter. Question number one. No, part A or whatever. Part A or from number one or whatever. Calculate the elongation of the rubber tube. Calculate the elongation of the rubber tube due to external force. Calculate the elongation of the rubber tube due to external force. Calculate the elongation of the rubber tube due to external force. Calculate the elongation of the rubber tube due to external force. Second one. Calculate the strain. Calculate the strain of the rubber tube. 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 Third one. Third one. Due to external force, due to external force, due to external force, is it generate, is it generate, is it generate, is it generate tensile stress or compressive stress? Is it generate tensile stress or compressive stress? Generate tensile stress or compressive stress? Tensile stress or compressive stress? Fourth one, calculate the value of for third part answer. Calculate the value of third part answer. Calculate the value of above part answer. Okay, very simple question. The basic level question, this type question not asking the exam. Only for your practice I given. Okay, now quickly refresh all these quantities by these all these names. I think you can practice by this question. Quickly do this question. First question, second, they are very simple. Only need to think for the final one. Final one also simple, but there are some unit conversions are there. Okay, we'll try. Simple, no? Are you complete? You complete. Simple question. Okay, first one is elongation is asking. Elongation don't need to calculate, no? The elongation is first part answer. The E equal, I told L2 minus L1. L2 minus L1. L2 is 68. 68. The final length is 68. The initial length is 8 centimeter. Sorry, 60 centimeter. Sorry, 60 centimeter. 60 centimeter. The answer is 8 centimeter. I told we can't put answers in centimeters. Therefore, we need to convert into meter. It is 0.08 meter. 0.08 meter is the elongation. First part answer is 0.08. Okay. Second part answer. Fatima. Second part answer is strain. Strain. Others, only two answers. Send me my answers. I think. Shohet, it centimeter strain. Strain is that unit for strain. Second one, the strain equal L1. Yeah, mistake. E over L1 mean the extension is 0.08 now. Now actually don't need, if you want, you can substitute in centimeters, because centimeter to centimeter cancel out. Then you can substitute 8 centimeter is the elongation. The L1 is 60 centimeter. 60 centimeter, then 60 centimeter to centimeter cancel out. It's also cancel out into 5, no? 5. Then 1 over 5 is 0.13. හරිද? Okay. 1 over 5 mean correct, no? 1 over 5 mean Kabir, 1 over 5 value is 0.13. No, 0.2, no? Then how it is all answers wrong? 0.2. You got 68. What you did mistake? Kabir, what you did mistake? I think my 8 into 5. Yeah, my. Sorry. Wait, today I don't have calculator. Yeah. My mistake. It is 0.13. 8 into it's 14. Sorry. 8 into 5, so 14. Then it's not cancel out. Sorry. It is 0.13 value. Yes. Yeah. You could. Into meter and get the value. Then if you got centimeters, no issue, because centimeter to centimeter cancel out. Then 0.13. Third one. If it tensile stress or compressive stress? Tensile or compressive? This one. Answers: tensile or compressive? Yes, tensile stress. Tensile stress. Fourth one. Now the question asks this: the tensile stress value. The tensile stress value. Tensile stress value. Tensile stress value. How we calculate? Sigma equal F over A. Sigma equal F over A. Then the force, the perpendicular force is no problem. It is 500. It is 500 Newton. It is 500 Newton. The radius is given in centimeter. Radius is given in centimeter. Erase this. I'll erase the second one answer. Forget some space. Now that's given the cylindrical object. That's a cylindrical object. Then what we need to get? The surface area, cross section area only we need to get. We don't need to get the total area of the cylinder. We need get the perpendicular force act on the cylindrical surface. Cylindrical surface. Therefore, that cylindrical surface, the cross section is a circle. Cylindrical surface cross section is a circle. Then we can get the cross section. It is pi r squared. 2 over 7. R squared means 7 into 7. 7 into 7. But the problem is this value is square centimeter. No, this value is square centimeter. Now, the 500 Newton divide by 7 to 7 cancel out. 22 into 154 square centimeter. Is it correct? No. After that, we need to 154 square centimeter. We need to convert into 150. We need to convert into square meter. We need to convert into. Then how we convert? How we convert? Divide by 100. Is it correct? No. 500 Newton. 500 Newton divide by 500 Newton divide by. Any idea? How we convert? 154 square centimeter. How we convert into square meter? The square meter is the standard unit. You know, to get the area, the standard unit is square meter. Any idea, Fatima? Habib? How we convert? What's your answer? Send me before convert. What's your answers? Kabir, what's the answer? Quickly, quickly. Hmm. 100. If I multiply by 100, is it convert into meter? No, divide by 100, Kabir. Divide by centimeters, we can convert into meter by dividing by 100. Multiplying, wrong. Divide by 100, we can convert into meter. But it is square centimeter convert into square meter. Therefore, 154 divide 100 into 100. That means divide by 10,000. Divide by 10,000 is the answer. Then we can, this is the answer. I think you can remember in future calculations, you can get more knowledge. Then 500 over, you can use calculators now. 0.0145. 0.0145. The answer is 32,000 value. Yes, 32,000. 32,467.5. 0.53 nm minus 2. Nm minus 2. Who is correct? Raise hand. Amina, are you correct? Dihini? Udanya? Yatish? Yes, Fatima is correct. Abir, are you correct? Fatima's answer also unit missing. Your answer must have Pascal or nm minus 2. Good, Kabir. Good, Dihini. Okay, I mean, now you can, up to now, correct, no? This, the final one only. Yeah, that's also okay. If you want directly the 7 centimeter, you can convert into meter by dividing 100. Then you can substitute. You can substitute. That's also okay. That's also okay. Okay, we'll do more calculation quickly. Then that's the basic part. I think only unit conversion, they are simple things. No, unit conversion you can practice. If you, I think you understood the basic part of today. That's the basic part of mechanical properties of matters. Any doubt? Not unit conversion. Unit conversion doubt also you can ask. Any doubt you can ask now. We have more 10 minutes. Okay, we'll do quickly one question. Quickly one question. Question number 2. Okay, draw this quickly. Draw quickly. If you complete quickly, send message. Write down like this. 120 Newton. 120 Newton. External force. 120 Newton. External force. On a is applied on a 120 Newton external force is applied on a concrete beam. Concrete beam is given in the figure. 120 Newton external force is applied on a concrete beam given in the figure. Given in the figure. The force applied 30-degree angle from the force applied 30-degree angle from the horizontal axis. 30-degree angle from the horizontal axis. Degree angle from the horizontal axis. Question part 1. According to the external force, is it generate which type tension, which type stress on the concrete beam? According to the applied force, according to the external force, which type stress is generated on the concrete beam? On the concrete beam. which type stress is generated on the concrete beam. Second one, calculate the stress of calculate the stress on the concrete. Calculate the stress on the concrete beam. Okay, that's your chance. We have only 4 minutes to complete class, finish the class. Okay, first part answer is simple. It is tensile stress, tensile or compressive stress, tensile or compressive, according to the external force, tensile or compressive. Amina, is it tensile or compressive due to this external force? Very good, Yatish. Yes, compressive stress. Good. Compressive stress. Compressive stress. The first part answer is compressive stress. Then the second one asks calculate the compressive stress. No, calculate the compressive stress F over A over A. Okay, now all send me. You have only 2 minutes. Quickly calculate the tensile compressive stress now. I need quick calculations now. You are practicing for exam. You have to improve your time management. Okay. Now there is a problem actually this question. No, the force is angular force. The force is an angular force. Now first of all you need to convert this force into the perpendicular direction, this direction. Then what is the method? That is force lesson part, that is force resolution. We need to resolve this force into the perpendicular direction. Perpendicular direction. Okay, this is 120 Newton, 120 Newton. When I resolve it into the perpendicular direction, 120 cosine cos 30 or 120 sine 30. උදන්නේ sine or cos. Very good. Sine 30, because the angle is there. The angle is this side. We resolve it into the opposite direction. In force resolution, if you don't know, if you not covered force lesson in 27 class, now we are doing, no? Next week we doing force resolution. You can catch it. In simply you need to remember, Fatima, I think you not completed, no? Simply you need to remember it is 30 degree, no? If it is resolved into, it is 120, no? If I resolve it into this direction, it is 120 cos 30. Angle direction cos. If it is resolved into this opposite direction, it is sine 30. That's only. Opposite angle එකෙන් අනිත් පැත්තට නා. Opposite direction from the angle, there is sine. Now this one, opposite direction from the angle, it is sine. Fatima, understood? Simply get. Next week we discuss into Thursday class. Next week means tomorrow we discuss. Tomorrow, yes. Simply I got. I'm asking from our new students. Okay, then now I think you got the reason why we can't this 120. 120 is not a perpendicular force. Then we need to convert the force into the perpendicular direction. Now it is 120 sine 30. Area is 25. 5 into 5, no? 25 square centimeter. Now 120 sine 30 mean you already know half. Sine 30 is half. Bargain. 25 convert into square meter by dividing both hundreds. Then 120 over 2 mean 60. 60 multiplied by 10,000 over 25. Over 25. The answer is 24,000. Very good. 24,000 nm minus 2. Nm minus 2. 24,000 nm minus 2. Okay, if you have any doubt, I can give you 2 minutes for you. If you have any doubt from today class, send me now. If you have any doubt in force resolution, yeah, Dihini, if you want, you can convert 5 centimeter into meter, and that's the one method. The same thing I did. If you want, you can get the area from centimeter, this area from centimeter, then you can convert it to meter. Understood? මම මෙතන කරලා තියෙන්නේ මේක area into 0.05. The same thing. 60 over this. Yeah, good question. $60 over. Yeah, same answer is coming. Now, okay. 60 over 0.05. Then square meter is coming. The same thing I did in this part also. You can check the same answer is what they doing here. You doing here 5 over 100 multiplied by 5 over 100. No, 5 over 100 into 5 over 100. The same thing I did. 5 into 5, 25. I divided it into 10,000. No, 100 into 10. I got others. I got this. If you want, first of all, you can one side length meter, then you can multiply area. If not, you can get the area from square centimeter or square whatever unit. Then finally you can convert into square meter. Both method same, both same. Okay, then the answer is 24,000. Okay, any other doubt? Other doubts? No? Now 25. Okay, then we can finish today if you don't have any doubt. Next week we discuss Young's module and Hooke's law. Young's module and Hooke's law, very important two theories, Young's module and Hooke's law. And tomorrow we start in 20 doing for the friction force is and tomorrow we start force resolution. Force dividing different calculation we can doing in the tomorrow. Anyone not completed, send me message at the 27 class as well. Okay, then good night, work well and work hard, complete all works, missing work, complete these days. I think now these days 3 times. Okay, good night.